Alright, we're back with Module 5 practice problems. And you can see here at the top, important thing, it gives you the conversion factor that 1.00 AMU, atomic mass unit, is equal to 1.66 times 10 to the negative 24 grams. When it gives you that on the practice problems, it does not expect you to memorize it for the test. So it will be on top of your test as well right there, so you don't have to memorize that. But do memorize Avogadro's number, 6.02 times 10 to the 23rd. Very important. Okay, so we're going to start with question number 6 on the practice problems. Oh, and make sure you do the extra practice problems this week and then check through them. I won't go over those, but very important, help you remember how to balance equations. Very similar to things you're going to see on the test, so you really want to do those. Number 6 on the practice problem says, how many moles of Cr, and what Cr, make sure you remember, it's chromium. How many moles of Cr atoms are in a 200.0 gram sample of chromium? So, what do we know? Always write down what you know first. It tells us that we have a 200.0 gram sample of chromium. Make sure that you, not only do you write your magnitude, 200, but you write your unit and you write what it is, what chemical it is. Very important in chemistry to keep track of all of that in your problems. So, then we need to look at our periodic table. We have grams, we want to convert to moles. We can use the molar mass of chromium to do that. So if we look at the periodic table, the molar mass of chromium is right here, 52.0 grams per mole. I want to cancel out grams. So the other way I can write this is 1 mole of chromium is the same as 52.0 grams of chromium. That means I can cancel out grams of chromium. I'm left with moles for my unit of chromium. So if I take my calculator and type 200.0 divided by 52.0, then I'll have an answer of 3.85 moles of chromium. Your answer needs to contain your number with correct significant figures. There are 4 here and 3 here. That means I keep 3 when I multiply and divide like that. 3 significant figures. And then mole, your unit of chromium, the chemical that it is. You need to have all 3 of those things in your answer to be correct. And when you use your molar mass here as a conversion factor, you just want to look at the units that you have, grams, and what you want to cancel. I start with grams, I want to end up with moles, so I want to put my grams in the denominator. It's exactly like saying I have 12 inches in 1 foot. That's exactly like multiplying something by 1, because 12 inches equals 1 foot, right? Just like when you multiply something by 3 over 3, that's multiplying by 1. Multiplying by 12 inches in 1 foot is multiplying by 1. 1 mole of chromium and 52 grams of chromium are exactly equal to each other, just like this, multiplying by the same thing. So if I had wanted to convert from moles to grams, I would have just used my molar mass upside down like this. 52.0 grams of chromium over 1 mole of chromium. And that is perfectly allowed. You can use it either way. Just use whatever works to cancel the unit you want to get rid of and keep the unit that you need for the answer. So that's the key thing to use in your molar mass. And we'll look at next problem, number 7. How many moles of sodium hydrogen carbonate, that's NaHCO3, and in Module 8 you'll learn how to name those yourself. That's an ionic compound because it has a metal and some nonmetals, but you haven't learned how to name more complicated ionics yet. That's sodium hydrogen carbonate, that's baking soda. So how many moles of sodium hydrogen carbonate are in a 125 gram sample of the compound? So I'm going to write down what I know. So I know I have 125 grams of sodium hydrogen carbonate. Now, it asks me how many moles there are. So how do I convert from grams to moles? Well, I need to have the molar mass to do that. When I have the molar mass, I want to cancel out grams. I want to end up with moles, so I'm going to put it like this. Now, to find the molar mass of sodium hydrogen carbonate, I need my periodic table. I look first at sodium. The molar mass of sodium is right here, 20 well, maybe I'll change colors so you can follow this. Molar mass of sodium is 23.0 grams per mole. Hydrogen, it's 1.01 grams per mole. Carbon, look at the periodic table, 12.0 grams per mole. And oxygen is 16, but we have 3 of them. So 16 times 3 is 64. Faster way to do that, if you cut 16 in half, is 8. If you double 3, it's 6. Oh dear, well I can't multiply it all, can I? So that would be 48. Good thing I checked, huh? 48.0 grams per mole for 3 oxygen atoms. So then I add up here 10, 14, 4, 5, 6, 7, 8. I get a molar mass of 84.0 grams per mole for sodium hydrogen carbonate. Now I have to round because the only one that's significant in the 100th place is the hydrogen. Everybody else is only significant in the 10th place, so I round to the 10th place. So I'll use 84.0 grams per mole. So since molar mass is in grams per mole, put here 84.0 grams in 1 mole of sodium hydrogen carbonate. So then I just want to take 125 grams NaHCO3, what it is, NaHCO3. So then I cancel out my grams of sodium hydrogen carbonate. I end up with moles of sodium hydrogen carbonate. Type into my calculator 125 divided by 84.0, and I get, let's see, number 7, I get 1.49 moles of sodium hydrogen carbonate. Okay. So make sure, again, I have 3 significant figures here, 3 here, so I'm going to keep 3 significant figures here. I tell what my unit is, and then I tell what chemical I'm using. So practice problem number 8 says, what is the mass of CuCl2? Well, first, what's the name of CuCl2? Okay, Cu, copper, Cl, chlorine, and then you have to decide ionic or covalent. Copper is a metal, chlorine is a nonmetal, so that's an ionic compound, so you aren't going to use any prefixes. This is just going to be copper chloride, and specifically it's copper 2 chloride, but you haven't learned that yet. So copper chloride. How many moles of, what is the mass of a copper chloride sample if it contains 0.172 moles of the compound? So, if I want to know the mass in grams, ooh, something is blowing down the street. Wow, this storm, Hurricane Sandy, very exciting. If I wanted to convert moles to grams so I can find the mass of this sample, then I need to know the molar mass of it. So I look here at my periodic table. I find copper here in the transition metals on the first row. Molar mass of copper, 63.5 grams per mole. Chlorine is 35.5, but I have 2 of them, so 71.0. Add those 2 up. I find a molar mass of 134.5 grams of copper chloride per mole. So, if I want to convert, I want to cancel out moles. I want to end up with grams. I'll erase that addition real fast so you can see. So I'm going to put my 134.5 grams per 1 mole of copper chloride. I'll cancel out my moles of copper chloride, and I'll end up with grams of copper chloride. Make sure I wrote it right. 134.5, good. So if I type into my calculator 0.172 times 134.5, then I get 23.1 grams of copper chloride. And my answer has a number, a unit, and what it is. Okay, so question number 9. How many grams are in 15.0 moles of Ce? So make sure you remember what Ce is. That's cerium. Cerium is found, the first of this intertransition metal series here. It's also called the lanthanide series. So Ce has a molar mass, cerium, of 140.1 grams per mole. So I could write 140.1 grams per mole of cerium. And I want to find the mass of 15 moles of cerium. Well, that just works perfectly to cancel out moles of cerium, end up with grams. So I type into my calculator 140.1 times 15, and I would get, well, this is a complicated significant figure moment. I would get this on my calculator, right? Well, that is going to be only 2 significant figures, but you see here I have 4 significant figures, and here I have 3 significant figures. So I'm going to have to use scientific notation to write my answer so that I end up with 3 significant figures. So the answer here, 140.1 grams times 15.0 would be 2.10 times 10 to the 3rd grams of cerium in 15 moles of cerium. So make sure you consider significant figures very carefully with that. And last one. Oh, how is my time? Oh, I'm over time. I'll come back for the last one in a minute. Oh, cuteness.